Hello and welcome to this undergraduate skills video where we're going to learn about various basic lab calculations which will be extremely useful as you progress through your degree. Now, why do you need to know these calculations? Well, it will allow you to safely determine the concentration of liquids in the lab whilst ensuring your experiments are at the correct concentrations. So without further ado, in this particular video, we're going to focus on molarity, and for this you will need to understand moles, relative atomic mass and molar mass. Therefore, I'd advise you watch the associated moles video before continuing. Okay, so in order to talk about molarity, we need to understand what it is to be a solution. In its most common form, a solution is a liquid made up of two components. The first is the solute, and this forms the minor component of the solution. Essentially, it is being dissolved in the solvent, which forms the major component of the solution. Therefore, something can be both a solute or a solvent depending on if there is more or less of something it is being added to. Now, the amounts of solute and solvent present within a solution determine the overall concentration of the solution. Essentially, this is the amount of solute per known amount of solvent, and it's important for us to know the concentration of solutions in almost all practical applications to ensure we are safe in the lab and to give meaning to some of our observations. Now, just as a recap, a mole is a unit of measurement for various substances and relates to 6.022 times 10 to the power of 23, meaning 1 mole of carbon will contain 6.022 times 10 to the power of 23 atoms. 1 mole of glucose will contain 6.022 times 10 to the power of 23 molecules, etc., etc. Now, it's important to remember that moles is just a way of counting something, giving us a quantity or amount of something which has its uses. However, if we want to look at the number of moles as a concentration, we use something known as molarity. Now, molarity is a very specific unit of concentration to express the amount of solute in a given volume of solution, and is essentially defined as the number of moles of solute per litre of solution, and is given the unit moles per litre. Now, this is commonly abbreviated to a capital M, meaning molar, and so a 1 molar solution is the same thing as saying 1 mole per litre. And so I guess the next question is, how do we calculate the molarity of a solution? Well, we have an equation for that, whereby molarity is equal to the amount of solute in moles divided by the solution volume in litres. Now, to help make sense of all this, we are going to look at some examples of calculating molarity, and as I said at the start of this video, you will need to know and understand what moles are and how we calculate them to make sense of some of these examples. So in our first example, a student dissolves 6.5 grams of sodium chloride in water to a final volume of 100 millilitres. The student wants to know what is the molarity of the sodium chloride solution. And so if we bring up our associated equation, we can see that the molarity is equal to the number of moles of solute divided by the final solution volume in litres. So now we can start adding information from our question into the equation, giving us molarity equals moles divided by 100 millilitres. Now, there is an error here in that our volume needs to be in litres and not millilitres, and so the first thing we need to do is convert our 100 millilitres into litres, giving us molarity equals moles divided by 0.1 litres. Now, to complete this equation, we need to determine the number of moles present. Now, this value isn't directly given to us, but we can calculate the number of moles by dividing the mass of sodium chloride in grams by its molar mass. And so we know the mass, that is 6.5 grams, and in order to determine the molar mass of sodium chloride, we need to bring in information from our periodic table, allowing us to calculate the molar mass of sodium chloride. This allows us to complete our equation, giving us moles is equal to 6.5 grams divided by 58.5 grams per mole, meaning we have 0.11 moles, which now allows us to complete our original molarity equation by dividing 0.11 moles by 0.1 litres, giving a concentration of 1.1 moles per litre, or a solution that has a 1.1 molar concentration, however you like to say it. Now, moving on to our second example, a student is in the lab and has 15 milliliters of a 1.5 molar solution of sodium hydroxide, And so the student wants to know how many moles of sodium hydroxide are present in the solution. And so if we bring up our associated equation, we can see that molarity is equal to moles divided by volume, and if we were to use some basic algebra, we can rearrange this equation to find the number of moles, giving the number of moles being equal to the molarity of the solution multiplied by the volume in litres. So now we can start adding information from our question into the equation, giving us moles being equal to 1.5 molar multiplied by 0.015 litres. And note that whilst putting our volume into the equation, I automatically converted it from millilitres to litres. And so now we can solve this, giving us an answer of 0.023 moles in our 15 milliliter solution. Now moving on to our third and final example, we have something quite interesting. A student is in the lab and has a beaker containing exactly 1 litre of pure water, and the student wants to know what is the molarity of the solution. Now you might be tempted with such a simple question to try and guess the molarity, however most likely you will arrive at an incorrect answer. No matter how simple a question might look, it's always worth doing your due diligence and using the associated equations. And so if we bring up our equation, we can see that the molarity of a solution is equal to the number of moles divided by the volume. So again, we can start adding information from our question into the equation, giving us the molarity being equal to the number of moles divided by 1 litre. Now in order to finalise this equation, we need to identify the number of moles, and so using some of our other equations we know the number of moles is equal to the mass divided by the molar mass. And so if we bring in some general information about water and information from the periodic table, we can start to calculate our values. And so we can use the relative density of water, which is 1 gram per milliliter, to determine the mass of water we have in the beaker, which is 1000 grams. We can now calculate the molar mass of water, which is equal to 2 times 1 gram per mole plus 1 times 16 grams per mole, giving us a molar mass of 18 grams per mole. We can now solve this equation, giving us 55.5 moles of water. We can now solve our molarity equation by dividing this 55.5 moles by our 1 litre, giving a value of 55.5 moles per litre, or a solution that is 55.5 molar. Now this value is quite interesting and it allows us to do some very interesting things in the world of chemistry, however that is for another day. That marks the end of this basic laboratory calculations video. Hopefully you found this content useful, easy to understand and can use it going forward in your experiments. Thanks for watching, stay safe and I hope you have a great day.